There we go. Okay, so today we're picking up on where we left off last week. Last week we ended talking about properties. Okay, so what are properties? Let's make sure we remember what that term means. Yeah. How something looks or acts. Very good. It's how you would describe something, right? And we gave the examples of being able to describe you based on how you look, but that doesn't really describe who you are, because then we'd also have to describe how you act, right, to get into who you really are. Does that make sense? Now, we use properties so that we can understand and classify different substances, okay? Today, we're going to be using dry ice to observe substances and how they change, okay? Because there's two different ways that a substance can change. The first is called a chemical change. And if you guys are on the slides, you see it. I have a spot I want you to fill in about chemical changes and physical changes, okay? If you just set that right there, thank you. Okay, so chemical change. A chemical change is when a new substance is created, okay? So new substance is created, okay? And just like my formula shows here, do you guys remember what CH4 is? We've looked at this a couple times. Anyone remember off their head? CH4 is methane. You guys remember methane? Okay. Methane, is it flammable? Yes, it is. That's right. So if I mix methane with oxygen, I burn it up, then I'll create carbon dioxide and water. So I'm sure you guys can visualize this at this point. That molecule of methane, the bonds will break, and so will the oxygen, and then it forms new bonds with those molecules to create carbon dioxide and water. Okay, so this is an example.
Kylie Holdaway, please go to Mr. Orton.
This is an example of a chemical change occurring. Okay, one substance, or in this case, two substances, becoming another substance. Okay, does that make sense? But here's the thing: can you see methane? Yes or no? Can you see methane? No. Can you see oxygen? No. Can you see carbon dioxide? No. Can you see water vapor that's just floating around in the air around you right now? No. We can't see these things, so how are we able to identify whether or not they exist? Well, how about with their properties, right? How they behave and act, just like we were saying earlier. So we can't see these substances, but we can observe their properties, okay? So a chemical change, we know a chemical change has occurred when there are new properties. Okay? So, for example, you guys have probably baked cookies, right? And the second best thing about cookies, aside from eating them, is the way they smell, right? I mean, I don't know about you guys. I don't know if anyone's ever, smelled a batch of cookie dough. I haven't, okay? But I have opened up the oven and been yeah, you smell those cookies. That's a good smell, right? Well, you've had a change in smell. That smell wasn't there before, right? And have you ever noticed, have any of you ever been in the other room, your mom's making cookies, and then all of a sudden you're she's making cookies, and they're, done. And you, know from how they smell that they're done, right? Because they reached a point where that chemical change has occurred, and now we're getting a new smell, a new property, right? But what happens if we don't take them out of the oven? And we just wait and wait. They what? They burn. And do burnt cookies have a different smell? Yes. They do, right? They can undergo another chemical change, okay, and get another new smell. Then think about this. Do cookie doughs, baked cookies, and burnt cookies all taste the same? No, they each taste different. So that's another property. Do they all have the same color? No, that's another property. Does that make sense? So we're having a change in properties, okay? Now, one of the ways that I've seen on some of the state tests and that they'll describe these chemical changes is that they'll say that these chemical changes are hard or impossible to reverse. Now, I don't love this definition too much, but I'll include it because I assume you guys will see it later. But with this hard or impossible to reverse, think about eggs. How many of you have fried an egg before? Before and after you fry an egg, do you think it's undergone a chemical change? It definitely has. Think about the whites of the egg. They've gone from this clear liquid to this semi-solid white sort of substance, right? They definitely change. Can you uncook an egg? No, you can't. You can't undo that. That'd be one where it's impossible to undo. Okay, you can't change that back. But some things can be changed back. It just needs a new chemical change to change it back to what it was before. Does that make sense? Okay? All right. The other type of change we can have is a physical change. Okay, a physical change. In a physical change, the substance might look different, but no new substance is made. So it might look different. In other words, it's changed in some way, but there's no new substance. Okay? For example, if we have a solid block of ice and it melts into a liquid, a solid block of ice and a liquid glass of water, they look different, but they're both water. Does that make sense? Nothing's actually changed between them. They're both water. Another example is like your hair. You get a haircut, whether the hair is growing out of your head or it's laying on the floor of the barber shop, it's still hair, right? It's not changed, okay? Now, a lot of times I see people list this as being easy to reverse. And for some things that's very true, but for other things I hate this definition as well, because like you get your hair cut, you can't reattach the hair. Once it's cut. You can't fix that. Okay? You could grow new hair, but that's not fixing what changed. Okay? So I don't love that definition either. Whenever I talk about it, I'll say, was there a new substance created or no new substance created? Does that make sense? Okay, so that's how I'll refer to it. All right. So, like I said earlier, we're going to use dry ice to demonstrate this, and we're going to try and show whether or not a physical or chemical change has happened, and you'll need to list evidence of it. So are you guys all on that table? We'll do 7 experiments. While I'm getting this ready, what do you guys know about dry ice? Raise your hand for me. Abron? It is. It's really cold, right? Okay, what else? Eileen? Okay, it's not made out of water, right? Good. Kate? Ooh, that's a good one. There's a solid and a gas, but no liquid in between. So when we go from a solid to a liquid, we call that melting. But in this case, we're going from a solid straight to a gas, and this is called sublimation. Okay, sublimation. So we use that term a lot today. And it's because of that sublimation that we get so many interesting characteristics from dry ice. Okay, but these chunks are too big. I need smaller chunks. So hold with me a second. Okay. Sorry, I need that in there for a different experiment. Okay. For our first experiment we're going to take a balloon and we'll put some pieces of dry ice in the balloon. Okay? But first I need to stretch out the balloon so it works better. Okay? So just kind of let it stretch out a little bit. And then we'll put some pieces in here. Okay? Now, why is it called dry ice? Go ahead, Dwayne. Never mind. Ben? Right, because of that sublimation, right? It's never wet, it's never liquid, right? Because we only ever refer to liquids as being wet. I always think it's funny, students, for some reason at this age, one of their deepest thoughts is water wet? Right? I'll hear people say that all the time. Well, it depends how you define wet, because really anything that's a liquid could be considered wet, depending on how you are defining the term wet. Okay? So, right here, I've got my balloon. Okay, no air in it. We'll squeeze all the air out. We'll tie it off so no air can get in. Okay? Now, here's where the magic begins to happen. Okay? I feel like you could really make an awesome magic show out of these demonstrations today, right? And you could sit here, you could talk to people and tell them some random hocus pocus story, right? As you're holding the balloon. But as I'm holding the balloon, what do you think's happening? Do you have any theories? Glenn? You think it's expanding? Why? What evidence backs up your theory?
Because this doesn't go through gas.
Okay. So it never turns into a liquid, just into a gas.
But it dissolves. The gas makes that expand.
Okay, so you're saying the gases take up more space than solids? Well, it looks to me like our balloon's filling up. Yeah? Okay. And that'll continue to do so until, once it gets to where we can shake it and we don't hear anything, it means it's blown up all the way. Does that make sense? Okay, so we've put dry ice in here. Has this been a chemical or a physical change? What's your evidence for a physical change? No new substance. It's still carbon dioxide inside the balloon. And has the balloon changed? No, it's still a balloon. Yeah. It's like going from ice to water, that sort of change, right? It's still water. Good. Okay? So, number one was a physical change. Okay, for our second one, we're going to take this solution here. This is called bromethyl blue. Okay? I often have students ask if this is just colored water. It is not colored water. And I might need to open my new container. I do. It's too empty for me to reach. But I've got a new one right here. Okay. Okay, put a little lid here in my test tube. Okay, and I just need a little piece. Drop that in there. Okay. What changes do you guys see happening here? It changed color from blue to orange, a yellow, right? Changed colors pretty quickly too. So do you think that's a chemical or a physical change?
Chemical.
Chemical, what's your evidence? We have new properties, right? It's a different color, so we're assuming that means it's a chemical change because a new substance would be created. Good. That changed so fast. I wonder if it's because of having a newer solution. Okay, let's check on this over here. Okay, right here, I just have hot water. That's all that is. Okay, hot water. Now, remind me again, what's this process called as it turns from a solid to a gas? Sublimation. How could I speed up or slow down sublimation? By adding heat or taking heat away, right? So if I take some of these pieces here and I put them into the hot water, what do you think will happen? Okay? I gotta brush this out of the, disperse this so we don't set off the smoke alarm or something. Okay? Well, that'd be the worst, right? We set off the smoke alarm. We never even got to play with fire. Anyways, so we've got a lot of this, looks like smoke at least, coming out of there. Is this a chemical or a physical change? Physical? What's your evidence? Yeah. Yeah, we don't have any new substances that are forming. We've just sped up that sublimation process. Okay, I think that's slowed down enough. I can walk away. All right. Our balloon's still getting bigger, by the way, if you guys haven't noticed. All right, what do we want to do next? Oh, I know. Okay, so I have some pliers. Okay, I'm going to put them here in the hot water. This experiment works better if they're hot. Okay. Then I've got a small piece of dry ice. I'm going to go like this. You guys remember in Princess Bride, it's the sound of ultimate suffering? Huh? What do you mean, Okay, let's do it one more time. Look, I can just press it against it and it just there in my hand. It's almost like it's going, why? Why are you doing this to me? Right? Okay, so was that a chemical or a physical change?
Physical.
What's your evidence? Okay, you're saying no new substance was made? Okay, so what's creating the noise then if it's not a new substance? What's that? You think it's the metal. So how then? Explain. Walk me through the process then, what you're thinking.
The ice is like vibrating.
Right, so as it sublimes, we see that it vibrates, right? That gas is squeezing past. It vibrates the metal of the pliers, and then the pliers are the ones making that noise. So it's not even the ice that makes that noise, it's the pliers that make that noise. Okay, kind of cool. Okay, so another physical change. Okay, let's come over to here. This solution is called phenolphthalein. I have to keep the tinfoil on it because it is a little bit flammable, so we try and contain the fumes. Turns to a gas very easily. All right. Drop that in there, bring her up. Okay. So what observations can we make about this? We see like a smoke that's coming out, right? But we've seen the smoke with a lot of things. What else? Getting lighter in color, you sure? Look at that. Okay, yeah, it goes clear. Kind of cool, huh? So is that a chemical or a physical change? Chemical change. What's your evidence? Changed color. Change of properties means we've got a new substance was created. Now, we've said in here that chemical changes are hard to reverse, physical changes are easy, but I also said that I really think that's not the best description. I think just saying that a chemical change needs a chemical change to reverse it would be better. But this substance right here, it's called ammonia, and this isn't one of them. I just think this is worth watching. So if I just take a tiny bit of that ammonia, changes it blue again. We'll put the rest in here. And it changes pink.
That happens so fast.
They do happen very fast, very quickly. Okay? So anyways, kind of cool. All right. How many do we have left? 2 left? Okay. On to my next one. This is my favorite one. Okay? So in this cup, I've just had dry ice sitting there. And what's been happening to it? It's been subliming, right? Turning into a gas. And carbon dioxide is a fairly heavy gas. So this cup should be full of carbon dioxide. Okay? Now, is carbon dioxide flammable? We've gone over this before. No, it's not flammable, right? If it was, birthdays would be very exciting. Okay? So I can actually take this cup, and because it's heavy, I can just pour. It puts out the candle. Okay? Once again, if you're doing a magic trick, I'd probably call this invisible water. Right? That's probably what I would call that one. So I take that, just pour it right on top. Isn't that cool? That's one of my favorite ones. Okay, because it's kind of, anyways, it's just kind of funny. Just like you can pretend like you're seeing the carbon dioxide, but you really can't. It's just, we ran out of carbon dioxide in our cup. Anyways, that goes to show you that it wasn't just like the cup. The cup ran out of carbon dioxide, and so it stopped working. Okay. All right. For our last one, I'll play it a little bit on the video, and then we'll turn the video off so that none of you guys are in the video, and we'll let you do a little bit more hands-on. So this is soap and water, and then we're going to put dry ice into it. It'll make bubbles, and I'm going to walk around, and you guys can play with the bubbles. Okay? Does that sound good? There's nothing wrong with it. It's not going to hurt you. You just end up with soap on your hands. Oh, yes. Was this a physical or chemical change? What's your evidence? Right. No new substance was made. It was still just carbon dioxide. We were just demonstrating one of the properties of carbon dioxide. Okay, very good. All right. Let's get one more chunk there. There we go. Okay. So like I said, I'll record this for a second, and then I'll turn off the camera and walk around so that you guys can all play with it. Okay? So put a couple pieces in here. See it bubbles up. Okay? And out, and then those bubbles smoke when you play with them. Okay?